Hi, welcome to Teardown Tuesday. Why do I have a Yankee $5 note here? One of these funny money, cotton-based crappy notes? In God we trust. Well, it's a good question because we have, for today's Teardown, one of these note validators or bill validators or bill acceptors or note acceptors, whatever you want to call them. The ones that you typically find in vending machines and things like that accept your bill. You feed your hard-earned money in there and it either accepts or rejects it and detects whether the currency is legal. So I thought we'd tear down one of these. Could be rather interesting. This one is a Money Controls. They're one of the probably not one. They're not one of the major manufacturers of these things, but they are one of the reputable manufacturers anyway of these bill acceptors, bill validators. And this is the MC2600 model that we've actually got here. And there's a lot of art and science which goes into detecting whether or not a note is genuine or not, and it's going to vary between runs of notes over time. They do actually change things, and different currencies as well. I mean, this silly US cotton-based funny money is just, you know, crap compared to, like, in terms of security, compared to a Australian designed technology designed in Australia, by the way. These are polymer banknotes we've got in Australia. I mean, we basically don't have a counterfeiting problem here in Australia because we use these very secure polymer notes. But sort of actually detecting notes like this, going to use different technologies, or can use different technologies to this simple US currency. Or is it that simple? Well, they've got, as you might know, they've got hidden watermarks in there. They've got security strips in there which fluoresce different colors, I believe, under UV lights, and you can tell the bills apart that way. They use magnetic inks, of course, and even some of the watermarks with the magnetic inks, they can resonate at a detector circuit at different frequencies based on what type of note it is. Because not only do you have to determine whether or not it's a genuine or fake note, but you have to determine, or the unit has to determine, the currency of the bill as well. Is it a $1, a $5, a $10, a $20, whatever. So as we'll see, there's various technologies that goes into this, and you can easily see this. For example, if you just really light up these notes from behind, it's not hard to actually see. Here we go. There's a hidden 5 in there, for example. You see that big 5 in there, which isn't, of course, on the reverse side there. So that's, there's an inbuilt watermark right there. And of course, there's the strip. You can see that. I'll zoom in. You can't see it on the note. It's basically right down there. But if we shine that from behind, you can see it's got USA 5 on it, and that security strip goes all the way down there. And I believe, don't quote me on this, but that fluoresces under a different color under UV light, and they can use infrared detectors and all sorts of other detection mechanisms to detect whether or not these bills are genuine. See, there's 5 going down there. You can see the watermark in there. So 555 plus the security strip. That's at least an absolute minimum that they've got going in these US $5 notes. And as I said, they do change things up occasionally. So these bill validators occasionally have to be updated with new firmware. They may not accept the new 2013 $5 bill, for example. So you've got to go out and update the firmware for this sucker. But yeah, so something like this note validator here is going to use various technologies. So I'd expect, and dimensions of bills, for example, they're probably going to, make sure it's the exact size and things like that as a minimum. So really, we expect to find quite a few sensors in here. And as you can see, they've obviously there's like one main control board in the back here. It's got various notes. We'll take a look at that, but it's got like a sensor module down the bottom of here underneath as part of the slot, and then they've got a cable running over there to the main board like that. And this money controls unit, basic dip switch interface, and then the vendor, the person who owns the vending machine, can just set it to accept various notes. It's designed to accept $1, $5, $10, and $20 notes, no higher. And yes, it is a used unit. I don't know if it actually works or not. It's obviously been pulled out of a unit, but anyway, you can enable and disable the various currencies. And then this is a very simple pulsed interface one. It has, as we'll see on the other side, does have other interfaces as well, but basically it can just give out 1 or 4 pulses per dollar. So that's how other circuitry in the machine can actually detect things. So you put your note in there, doesn't give change or anything like that. It just accepts the note and either puts it in the cash box in the back, which we'll take a look at, or just throws it back out. It actually came with the cable to hook up to it, and it just plugs into here. I mean, it does have serial interfaces. There you go, and it's got a download diagnostics as well. You can, for this particular brand, you can buy a diagnostic box which hooks up to the PC and allows you to extract data out of it or change it, or maybe even update the firmware remotely. I'm not entirely sure about that, but this one can be as simple. This one's 120 volt AC model. You can get ones based on 12 volt DC and stuff like that. So that just plugs in there, and all we've got is basically 120 volts AC in and just a relay contact out, or a a pulsed contact out, which gives the number of pulses based on the bill and whether or not it's accepted it. That's it. So incredibly simple interface, just 4 wires plus ground. So obviously the bill goes in the front there. There's a sensor board in there which actually detects all the stuff. There's a processor board in the back, and then this big thing looks all complicated, but it's not. It's very simple. You just release that clip, and this is the money box. There it is. That just it's got a couple of springs in there, and that just fills up with money. Obviously, I'm not sure how many actual bills you can fit in there. I don't know. What's the average thickness of a bill? No idea. But you might get 500 or bills or something like that in there. So I'm not sure how long that would last in a typical scenario. But there you go. There's the diagnostic stuff for it, and yeah. And basically, they've just got some belt and pulleys which then suck the note through here. I'm not entirely sure exactly how. I assume this one, if it rejects it, will spit the note back out. So maybe it only comes part of the way in, because it's not like the note sort of pops out the back here and then either gets directed into there or spat back out. So it probably comes like halfway in, detects. If it doesn't detect that it's a valid bill, it just reverses the motors and whoop, shoots it back out the front. But yeah, that's all there is to it. Mechanically, pretty simple. And if we take those 4 screws off the front, bit of dust in there. It smells, but we're in, and we have our first look at the main board there. That's the bottom of the main board. They've got very nicely aligned SMD resistors there. I rather like that. They've got a flat flex cable going into, it looks like they've got a top sensor board, and they're the status LEDs there. I didn't see that, but they obviously poked through the front, and that's what we had on the back here. That's what they had on the unit, the back of the unit here, the diagnostics. Maybe I should actually power this thing up before I take it apart, just in case I goof up some of the mechanicals or something like that. I think I might give it a go. Okay, I think I've got the pinouts correct. This is, of course, a US 120 volts AC, 60 hertz. So I'm using my variable frequency converter here to generate just that. I've got the ground wire hooked up as well. So hopefully the magic smoke doesn't escape. Let's give it a go. Whoa, that sounded good. All the motors went, so let's whack in our funny money. I don't know which way up. There we go. It gives you a photo, the head, I guess. There we go. Let's give it a go. Give it a bell. Hello. It's not detecting. It's not detecting my note. No. No. Oh, fail. Oh, there we go. We had something. There we go. No. So it's obviously rejected that straight away. No, there we go. Oh, What I did there is flicked a dip switch on the side here, which just changed it from the pulse from vendor serial to pulsed protocol. So maybe, you know, that's what was going on there, but it doesn't like my $5 note at all. I've got 2 of them, so I'll try another one. And no, it does not like that in the least. No. Of course, I'm pretty sure the note has to be up there. I mean, you know, Yanks are probably laughing at me because our ones here pretty much accept the bills basically in, you know, any orientation at all. But yeah, that's not, no, it's just rejecting my $5 note. Unbelievable. Like, I don't know, is this a new note? I don't know, when was it manufactured? You know, you'd have to know, like, does this support the latest firmware for this $5 bill? I've got $5 enabled on the dip switch on the side, but yep, it's not accepting. Bummer. Does it have to be properly vertical? Is there something going on there? No, sometimes it doesn't go in all the way at all. No, no, loser. It's kind of doing the business, but it's not accepting my note. Bummer. Now let's just have a look at the back of that when we shoot that bill in, shall we, and see what... Yeah, as I thought, yeah, it goes like partial way in, and then so it doesn't feed it all the way in. Only when it accepts it, and it gets to that point, it processes it, accepts it, will it feed up the whole way, and then put it in the little storage container. I just popped off that top cover there, easy. We've got some cutouts in the board here for 3 large caps there, and of course there are obviously a bit of a premium on space there, so, and there's not much circuitry on the board, so they've decided to make some cutouts there. Not you know, not uncommon for space sensitive applications to do something like that, but let's get the rest of this board out, and we'll take out these ribbon cables here and see what's on the top side. Sort of levered that out, and it looks like they were held in with clips, so this board should just pop out. Too easy. There's one more cable or a lattice semiconductor part. We're going to have a good look in here, but check that out. Hey, interesting. It's a rather interesting board. You know, there's quite a bit of logic going on happening over here. There's a lattice PLD over here. There's a 6800 processor, which we'll take a look at. There's the PROM, obviously, for the thing, and basically we're in sandwich sort of in the middle here is the mains switch mode power supply. Obviously there's our switch mode transformer there. There's our high voltage caps, 200 volts a pop, and yeah, I mean, you know, input fuse there, and we've got some protection, but we've got, I mean, obviously, you know, not a huge sort of thought given to differentiating or isolating these sort of, you know, the low voltage stuff from the mains side here. So, I mean, there's, you know, the dip switch sort of right next to the main input filter caps. You know, you got to, it's crazy. Anyway, we've got some regulators, you know, some low voltage regulators, low side regulators around here. Maybe they're like some little opto couplers or something like that for the digital out. I mean, here's our mains input here, so it's popping in here. So yeah, it just looks a bit real, you know, it's a just messy business. I sort of, you know, not a huge amount of thought has gone into that. It's sort of, you know, hack and slash kind of design, I think. Anyway, we've got ourselves a couple of optical detectors here. This one here is for an optical encoder wheel down there, if you can see that properly. So that obviously turns around with the motor just to ensure, I guess, that a bit of feedback to ensure that, yeah, the motor has actually turned, and the thing, you know, maybe for slipped bills or something like that, perhaps some sort of detection. Another one here, which, you know, mates up with this over here, which I'm not sure, that just looks, I'm not sure how that moves at all, that little plastic. It's just like a plastic tab, so I'm not quite sure what that one's doing there. Maybe some sort of, you know, this thing's going to have maybe, you know, a little bit of anti-tamper stuff in it as well, but I don't really know what that's doing. I mean, phew, strange. What does it detect that this whole mechanism has popped out of the bottom? I don't know. Now that firmware sticker might explain why possibly it didn't accept my note. One of the reasons, look, it's dated 2002, so 11 years old, unless they've, unless the sticker's old and it's reflashable or something. Let's have a poke under here and actually have a look. Yeah, that's really crusty. Looks like it's been on there for 10 years or more, that's for sure. Let's have a look at what we've got. There you go, it's an AM29F002, so it's a 2 megabit from parallel flash PROM. So yeah, it is reflashable, but I doubt it has the internal ability to reflash remotely. You probably have to take it out, whack it in your programmer, and do it that way. Now, to understand whether or not that flash chip contains the actual firmware for the processor, or maybe contains all the data and the images and all sorts of other stuff for the various notes and things like that, all the data seems a bit big for that. Anyway, to figure that out, we need to take a look at the exact type of processor here. And they've got a Motorola, now Freescale, of course, EMS Classic, MC68HC11. But, of course, the 68HC11 comes in endless varieties. So, some contain internal PROM, some don't, E-squared PROM, this, that, blah. They come in a million different types. Well, this is actually the F series chip, and you can't confuse it with other series. There's like the E series, different again, and so you've got to look at the F1 and then the CPU 5 after that. So we need to go into the datasheet and have a look at the specific type of chip to see whether or not it contains an internal ROM or not. And I check the datasheet, which I will link in down below for this thing if you want to follow along at home. No, this one does not contain an internal ROM, although it's got an internal E-squared PROM, only 512 bytes. It's got like 1K of SRAM, not a particularly powerful processor at all. It does have a built-in 8-bit multi-channel ADC though, which they're probably using for some, to measure some of the sensor stuff, so we'll have to check the other chips to see if there's an external one there, but yeah, they're possibly using that. So obviously this is the firmware for all of that. And I was going to say that, because we've got a Lattice PLD over here, maybe they could have interfaced the memory through that to sort of, externally program it and then sort of, route it through to the CPU here. But by the looks of that, no, it's just going direct. Oh, I can't see anything on the back there, but anyway, internal layers there, but that's it's running straight over. So I think to reprogram that sucker, we need to, you need to pull it out, or the, service tech comes along, pulls it out, reflashes the chip, and then updates it for the latest currency. So most likely, yes, this contains, unless they didn't change the sticker, contains the firmware from 2002. So any notes after that, if they have changed, this thing likely won't accept them. And the PLD here is an old Lattice Mark IV PLD, only 64 macro cells. It's pretty tiny, not much doing there, but obviously they need it for some sort of glue logic in there. Not sure what. And we've got ourselves an ISSI external SRAM there. In this case, 32K times 8. A big whopping SRAM, because this thing doesn't have much, as I said, like 1K. So obviously they're using the PLD as some sort of glue logic to maybe, get that into the processor. Although, should be able to just whack that straight on the bus. For the mains power supply, we've got ourselves a power integration top switch device, the top 247R, and that's just a flyback controller. There's our flyback transformer down there, and nothing special going on the main side of things there. Just got a fuse on the input there, common mode choke. Our bridge rectifier is 4 separate diodes underneath there, our filter caps, and then our main flyback controller, and Bob's your uncle. And there's our feedback opto coupler hidden under there, and as I said, just very messy layout. I mean, I don't like it at all. Look at it, it's not over near here, near the photo interrupter, and it's just, it's terrible, awful layout. And the only other thing of note on here is this Texas Instruments TLV56 EEVblog29, and that's an 8-bit DAC. Probably not a huge surprise to find that on there. So they're using the DAC to drive some sensor stuff probably, and the built-in ADC, as I said, in the HC11 over there, reading that back. But a whole bunch of transistors, not sure what's going on there. Maybe that's a part of all the sensors. And what's that little sucker? No idea. Looks like a 74HC14 there. We've got, you know, it's part of the secondary power supply here. There's an LN324 by the looks of it. And this A2595 is just an 8-channel open collector driver, just like the classic ULN 2803, for example. But, you know, here it is over here. It's obviously driving the output pins, but where are they? I mean, they're all the way, all the output connectors are all the way over on this side of the board. Crazy. And same with the Max 232 driver. I mean, where's the connector? Way over here somewhere. And actually, just with the layout of the board, I just noticed something. You can see, you know, it's a multi-layer board. You can see the internal, the darker green in there. You can see that it's flood filled all the way through, even all over this mains section here. Complete ground plane right around the whole blinking lot. And that's also, you can actually see that a similar thing happening on the top. I can't get a good light angle on that, but you can see it definitely happening here. And here's the mains input here, right? This connector here. Here is the two mains input, right? You know, active and neutral. There it is. There's the ground input, of course. The ground input is actually connected through to the ground plane on the bottom, and they've got this trace running over here, and that's all connected. So the ground is connected through, and of course this is a flyback mains power supply, so the outputs are going to be isolated from the mains. But look at the clearance. Look, just around the pad there. Are you shitting me? Like, the person that laid out this obviously has no clue about A, meeting any standard, I guess, and because I think it's unlikely to, and you know, B, just how to lay out boards for clearance. I mean, it's just an absolute mess. And to have one solid ground fill all the way with just that little pissant amount of clearance in there, what is that, you know, a couple of millimeters? You've got to be shitting me. Alright, well, enough of the PCB, because there's nothing really special on there. It's a processor with a DAC and an ADC and maybe a bit of analogy stuff, and that's about it. So let's see if we can get into this sensor part. I think that there might be a top and a bottom board there. You can just actually remove the entire sensor thing like that, and lost some pulleys and things. Oops. Yeah, I did take out a few screws, and well, I'm a few screws loose. And sure enough, there are two sensor boards in this thing. This is the bottom sensor board, and nothing special on the back side there. It's just a double-sided board, and it looks like there's no huge amount of circuitry in there, but we've got a couple of LEDs and things. We've got our note edge detection here, so you know, clearly there we've got a LED here and a photo transistor over here, so as soon as you put the bill in, it interrupts that, and it knows to then feed that through with the various rollers on the top and bottom side here. Here's the front rollers, which I've actually taken out. They're little tiny rollers like that, and they've got springs in behind those. So yeah, it can then start, once it detects that, bang, it just starts pulling it through. And at first glance, this looks just to be an optical solution, really. I mean, we've got some LEDs in here, and basically three by the looks of it. Actually, not sure what's under there. Not sure what that top part there is. I don't know. But yeah, they seem to match up with the sensors. We'll have to get this board out in here, of course, but they seem to match up with the sensors on the other side, which makes sense, of course, because they're going to be shining various wavelengths of light, either visible or UV or infrared, or a combination of all three with the different LEDs through the notes to actually detect things as it goes in. But nothing hugely complicated there at all. I actually don't see a magnetic detector at first glance. Anyway, let's take the board out. There you go, there's the top side of the board, and it looks like it is just an optical solution, as I said, because look, we've got a LED here, of course, which is, you know, I don't know, that could be the IR one, I'm not sure, but we've got an interesting angled, like, you know, photo transistor or some sensor down in there, and it's on like a 45-degree angle, which is rather interesting. It'll be interesting to see if that's matched on the top side and why it's actually angled like that. And we've got two extra LEDs in here. Once again, they will probably be matching on the other side with photo transistors over there to actually detect that. So yeah, really, I don't see any magnetic, unless it's on the top side board. On the bottom side board here, I don't see any magnetic detection at all. And as far as the chips go, we've got an LM336 2.5 volt voltage reference there, and just a couple of dual op amps, LMC 6062 and LMC 662. So really, not much doing at all. Couple of transistors there, presumably for driving the LEDs at quite a high brightness, I'm assuming, but apart from that, that's it. And that plate on the top side there, I maybe had a thought that maybe it's some sort of filter or something, but I don't know. I think it's just likely just masking out the extraneous light, perhaps. Now I've got the top sensor assembly here, and that of course just fits in place over there like that, and the note just goes between the two slots there and then just pops up. Looks like we've got some other LEDs slash sensors there. Yeah, there we go. There we go. There's a couple of... Oh, no, they're just... Oh, it's a light pipe. Okay, that looks like it just might be a light pipe, because this has no circuitry going... I don't know. Is there circuitry going up to that? No, that just looks like... See, there's no wires, I mean. Sorry, so that just looks like a light pipe feeding in from there and coming back out there. So the board, the top sensor board, is in here, and yep, they've probably got an LED and a photo transistor on the other side, and then just detecting that the bill's actually made it through there. I don't think that's part of the validation of the note at all. But anyway, if we flip that open, we can see that they're essentially duplicates. Oh no, there we go. One side, they aren't lined up. There we go. So they're different alignments there. So two different combination of LED and then sensor. So that's why they've put that in, to mask out the light from one side to the other. So there's two paths there that they're trying to read. There's one path lined up with the note there and one from the other, and we probably saw that. That's probably the internal strip, perhaps lined up with the text on the internal strip. I don't know, but it looks like exactly the same array with the LED and the sensor and two other LEDs on the sides. They look like LEDs, and those down there, if we can see it, look like the two matching photo transistors, as I said. Yeah. So we get in. Looks like there's four optical detection points. This one here, this one over here, which just goes straight through the note, and then two separate paths across the note there. So I don't know. You know, feed that sucker in there. Feed old Lincoln in, and what do they line up with? I don't know. Not much. Your guess is as good as mine, exactly what points of the note that they're actually detecting along the path there. There's a good look down into that photo diode there, and that is one big ass sensor die on that thing, that's for sure, with a nice clear window over the front. It could even be you know, filtered in some way, who knows, but yeah, I mean, is that a UV or is it an IR one? I'm not entirely sure, but they're obviously quite serious, more serious with that one than just these smaller ones. And there's a smaller photodiodes down there. That does look like it's got some sort of maybe some sort of filter lens there, perhaps. I'm not sure, but it certainly is different. I mean, this one is much clearer, and you can just see the gold inside there. This one does look like it's, or maybe it is, no, maybe it's the same. Maybe it is clear and it's just an optical illusion, really, that it looks like there's that coating's a different color. It could just be completely clear. Oh, sorry, I completely forgot these two extra LEDs over there and there. So they got a couple of, so they got two extra points there. So sorry, 1, 2, 3, 4, and then 5 and 6 separate optical detection points. There we go. There's a much better view. There we go. We've got our metal can sensors here, and then we've got our 3 diodes here, and those ones, those little suckers, yeah, they're most likely, based on the color, of course, the UV sensors there, and these are the you know, they could be infrared or whatever, I don't exactly know. We have ourselves a part number there, folks, SLD67HF2 1902. Brilliant. To Google, and sure enough, that's a Silicon X photodiode. Found the datasheet real easy. I'll link it in down below. A spectrum range of 400 to 1100 nanometers, which puts it covers basically all of the entire visible spectrum plus the infrared up at the higher part. Doesn't do ultraviolet. So clearly these two inner sensors here, so this will be an infrared LED, of course, and infrared photodiodes. But unfortunately the part number is going to escape us on that, but just by the color of that and the fact that I know that you know, these note validators often do infrared and ultraviolet UV stuff as well, then that's clearly, you know, almost certainly UV. And there's our upper sensor board, once again practically identical except with matching sensors. So on this one we've got our infrared diode, our infrared photodiode, and which the other one sort of goes about here on the other side of the board, so that gets those two strips in there. And then we've got ourselves our photo transistor over here and over here, which made up with the LED on the other side on the other board, and then likewise these two LEDs here match up with the photodiodes on the other board. So it looks like we could have 3 wavelengths operating here. UV, this is most likely the UV sensitive photo transistor there, and it's definitely like it's a photo transistor arrangement, you call it, because it's actually got the Q designator down there instead of the D designator. By the way, that's why, you know, this one is actually a photodiode, so they have actually called it D down on the designator there. These ones are likely infrared, but they could be, you know, I don't know. You know, you would have to know what that particular LED here is, because these are quite broad range. They can do anything from visible, as I said, up to the infrared range, no problems whatsoever. So, but likely 2 infrared ones in the center there, maybe some visible stuff happening over here, I'm not sure, but you know, it could be other wavelengths, I'm not entirely sure, but these are almost certainly UV, and well, Bob's your uncle. That's it. As I said, there are a couple of LEDs on the back here, but I'm pretty sure they're just actually detecting that the note's actually gone through, and not the fact that because that's a position. And if we go back to our first board here, we can see the edge detecting. This is obviously our first edge, and then on our top side board we've got our second edge detection with this diode and that light pipe just feeding back over there. As I said before, that just detects that the note of the second edge, so it knows how far the note's gone through. As soon as it hits that point, it knows the timing to turn on the LEDs and read the data back at a specific point as the note goes through, because you wouldn't do it over the whole strip. You'd only do it at a specific point on the note which has that particular security feature that they're trying to read. So actually I'm a bit disappointed that that's all we found, really. I mean, basically we've got 6 different detection points there using, you know, at most 3 different wavelengths of light. There's no magnetic stuff happening there. There's no width detection, by the way, of the note or anything like that at all. So, yeah, this is a pretty rudimentary bill acceptor. And of course, people are going to ask, well, how easy is it to, you know, fool these sort of things? Well, I'm not entirely sure. You know, you'd have to do a lot of tests, but considering that, you know, no magnetic sensor, it's just, you know, some optical stuff, I don't know. Maybe it, you know, if you really got down to it, you could possibly try and fool these things perhaps, but by the time you went to that effort, geez, I don't know, to get, you know, a $20 thing out of a vending machine, geez, not worth the effort. And I won't bother taking that apart. There's nothing in there. I mean, there's 2 motors. That's what our 2 wires hanging out there for. That's, you know, nothing special whatsoever. It's got that optical encoding feedback positional wheel, as I said, but that's about all she wrote. So there you go. I hope you like that. That's what's inside a pretty rudimentary. I mean, a more modern one, a more advanced one is going to use lots more advanced technology than this one. I mean, there's no image matching, there's no camera, there's no, you know, nothing like that, which you might possibly get in a more modern one, but it, you know, it does the job. Maybe it's just for a simple vending machine that just reads 6 points at various light spectrums, and well, that's all there is to it. So there you go. If you want to discuss it, and if you've got any more info on exactly, you know, what might be going on in the various US bills, because I don't know US currency, that stupid, funny, cotton, funny money stuff. I don't know about that. But anyway, if you've got any more detail on exactly what's going on here, please let us know. It could be interesting to you know, power this thing up and get the time in and figure out what the wavelengths these LEDs are actually working at and stuff like that. Maybe I could do that in a second video. We'll see. Anyway, if you like Teardown Tuesday, please give it a big thumbs up. And if you want to discuss it, the EEVblog forum, link down below, is the place to do it. That's down below on YouTube, down there. Or if you're watching the embedded version on EEVblog.com, then the links are going to be up the top there. But because you're looking at the blog website, you already know that. So I'm wasting my time. Catch you next time. And I still can't get over the layout of this power supply. It's just awful.